Hello, today we're going to talk about solving quadratic equations by factoring. Let me just take a minute to quickly review a couple of things. This chapter on solving quadratic equations, there are 5 techniques that we could be looking at, and we're going to look at the second one today. The first one was solving by graphing. The second one, solving by factoring, and that's what we're going to do today. Solving by using completing the square. Complete the square. Solving by the square root property. And finally, solving quadratics by the quadratic equation. Quadratic equation. Okay, so we've just taken a look at this one, and this is a kind of a foundational idea. We're going to talk about factoring, which we've talked about before, and it's now that we're talking about it a little more formally. We're going to see exactly what's happening here. All right, let's go back and talk a little bit again about some wording. We are looking for the spots where our graph crosses the x-axis. These places here have 4 names. We could call them 4 different things. We could call them the x-intercepts, because that's where they cross the x-axis. We could call them the roots, kind of like the roots of a tree, and you'll be hearing that word a lot in this section. And we could call them zeros, because those spots happen to be at a place called some x and 0. It's called a 0 because the y value here is 0. Some x value and a y value. And they could also be called solutions. And the word solutions, again, seems a little bit like somebody says, well, does that just mean find the answer? Well, it does mean find the answer, but it also is specifically referring to these 2 places. So when you see the word solving quadratics, what it's saying is find those solutions. Solving, solution, same word, right? And it's asking for these x-intercepts, roots, zeros, solutions. They're all the same thing, but we're asking for that. So when you see the word find the solution, that's what it's asking for. All right, we're going to go back and take a look at how we solve quadratics by factoring. We're not going to spend much time on this because you've heard this before, okay? All right, here's a very simple quadratic equation. And this quadratic has an x squared in it, and x squared tells us that there's always going to be 2 answers. So there's going to be 2 answers to this. And so step 1 in solving quadratics is set the original equation equal to 0. So I'm going to move this over here by subtraction. Oops, by subtracting 6x from both sides. Okay. And there you go. Now, it's not as simple as just setting it equal to 0. It is saying, well, if we're setting this equal to 0, this, which is normally y, we're letting it be 0. And so that's telling people that we're trying to find that spot, some x value 0. The 0 here is the y value that we want it to be. So if y is 0, what is the x value? So the first step is to set it equal to 0. The second step is to factor it, and that's where we're at here. We're going to factor this thing, and I'm going to start with my factoring toolbox. Can I take something out of both terms, the greatest common factor? Yes, I'm going to take out x, and I'll leave behind x minus 6. Now, this is made up of 2 factors, x and x minus 6. And now we're going to use the zero product property, to solve this. And the zero product property says if 2 things are multiplied together and they equal 0, one of them or both of them could be 0. Either this is 0 or this is 0. One of them has to be 0. If the product is 0, what times something has to be, one of these has got to be 0. So we know that x could be 0 and x minus 6 could be 0. So we're going to set each one equal to 0. Kind of split the problem here, and when we do that, we're saying I'm looking for two answers here. So I'm going to use the zero product property and set them each equal to 0. And this one's already done, and this one is x equals 6. So my answer is two answers, two things that x could be. And if I go back up to the original problem, I'll see that if I stick 0 in there, it's true. And if I stick 6 in there, it's true. And I can't stick anything else in there to make this true. So we have just solved this quadratic by factoring. Again, set it equal to 0, factor it, and then use the zero product property. And here you're going to split into two equations, both of them equal to 0. Okay? So there's your step. Now that's basically it. Let's do a little harder one here. By the way, the question is going to ask you to find the roots. The roots. In this case, there are two roots to the answers there. Let's take a look at a harder one. All right, here's the second problem. And our first thing we're going to do is set it equal to 0. So I'm going to move this over to the left again. By the way, I'm trying to keep the x squared positive. If I let the x squared become negative, it gets harder to factor. So if I subtract 64 or add 64 to both sides, I get this. All right. Now we're going to factor this, and again, you're going to have to go back and take a look at your factoring tools. What two numbers will give me 61 times 64? What two numbers will give me 64 when I multiply and negative 16 when I add? Well, that would be negative 8 and negative 8. Now I notice that since they're both the same, that maybe this is a perfect trinomial square. In fact, it is. If you recall, we have a shortcut for factoring the perfect trinomial square. We take the square root of this first term, which is x. We take the square root of the last term, which is either 8 or negative 8. And then we say, oh, if I multiply the inner and the outer terms, do I get this middle term? Well, sure I do if these are negative. So I got negative 8x and another negative 8x. That's negative 16x. Okay, so it does factor using that particular factoring technique to find perfect trinomial squares. Now, by the way, we can write this as x minus 8 squared. That's okay to write it that way. But we're going to solve one of these, and they're both the same, so I only really need to solve one of them. X minus 8 equals 0, or x equals 8. Now, there are two answers here, and somebody say, well, it's really only one answer. Yes, there is only one answer. This is a parabola where the only solution is at 8. It's right here. That means if it's got only one solution, it must be a parabola that sits or hangs at that spot from the x-axis. Turns out it is. This is a single answer. However, we call this a double root. And double roots intersect the parabola intersects the x-axis right at the vertex because it's got only one solution. Let's look at another one. All right, let's tackle this one. I want to solve the quadratic, so I want to set it equal to 0. Now, rather than move this item to the left, the 3x squared to the left, I don't want it to become negative, so I'm going to actually move both of these the other way. So I'm going to get 0 here, and this is 3x squared minus 5x and minus 2. So when I subtract these from both sides, I want to keep that x squared term positive. That's kind of critical. All right, let's factor this. 3 times a negative 2, a times c. 3 times a negative 2 is a negative 6. What two numbers will give me negative 6 when I multiply and negative 5 when I add? Well, see, that would have to be a positive 6. No, a negative 6 and a positive 1. Their product is negative 6 and their sum is a negative 5. Some are going to look at this and say, well, it's got to be a negative 3 and a negative 2. Well, that's not negative. That's a negative 5, but that would give me a positive 6 as a product. This can't be it. That's not the right answer. So these are my two numbers. So we're going to take and rewrite this, splitting the middle term, if you recall. Minus 6x plus 1x. You may have to go back and look at your toolbox again to see how to do this again. So I've split the middle term here and here. Okay? I've taken and rewritten that quadratic with the middle term split. All right. Now, underline the two groups. We're going to factor by grouping here. What comes out of this first group? Well, it's 3x. Leave behind x minus 2. Copy the leftovers. What had to come out of this group? Well, a positive 1. So I'm marrying the pieces, 3x plus 1 and x minus 2. Okay. Now set each of these factors equal to 0. Split the problem. This one's easy, x equals 2. And this one, subtracting 1 from both sides and dividing by 3, I end up with x equals a negative 1/3. Once again, we've got two answers for this problem. Okay? So that's how you'll do these over and over and over again. Okay? Now we got one other kind of problem to take a look at on your assignment tonight. All right, you're going to have several problems to write on your assignment tonight with that look like this. It says write a quadratic equation with 1/2 and negative 5 as its roots. Write the equation in the form ax squared plus bx plus c, where a, b, and c are integers. What it's asking for us to do, again, is to come up with a quadratic equation. Now, we need to give you a little bit of a little help here in understanding a formula. It's important. Okay, if you noticed, every time we solved an equation, we had something like x minus 2 and x minus 5 or something like that. Okay, and whenever we solve these, the factor and the answer, there's a relationship between the two. Look, the factor is x minus 2, and the 0, or the root, is x equals 2. Okay, let's say the factor is x plus 5. The 0 would be x minus 5. These are the factors. These are the roots. There's a relationship here, and here it is. Write this down at the top of your paper so you have this as a note. If x minus r is the factor, then r is the root. Okay? If x minus r is the factor, then r is the root. Okay? If x minus r is the factor, then r is the root. Okay? So we're gonna take this information. I'm gonna take the number 1/2 and the number negative 5. And I'm going to go down here and say, okay, those are the roots. So x minus 1/2 has to be the factor. And x minus a negative 5 has to also be a factor. Notice, if that's a factor, if that's a root, then this is the factor. Roots, factors. Roots, factors. If the root is r, the factor is x minus r. Now, there are two numbers which are factors. And if we FOIL these, we'll get a quadratic. So I'm going to go to the next page, the top of the next page, and do just that. Hang on now. Okay, so again, if the roots are these, then the factors will be x minus the root. And in this case, it turns out to be a double negative, so we have x plus plus, and x minus a minus is plus. Now, if I FOIL this, I will get a quadratic. And here it is. It's x squared plus 5x minus a half x minus 5 halves. Okay? Or I get x squared plus, what is that, 4.5x minus 2.5. And that is a quadratic. And you could write this as an answer. However, the instructions that I said that A, B, and C had to be integers. Well, these are not integers. So I'd have to figure out, well, what do I have to do to make them all integers? And since this is equal to 0, I could just multiply everything by a number here. But there's an easier way to do that. And so I'm going to back up and come up with a little process that you can use to actually come up with integers. If you get a fraction in a problem, we're going to do a little trick here, okay, to get rid of the fraction. Now, since this is equal to 0, I can multiply both sides of this equation by something, and I won't actually change the equation for finding the roots. The equation will be changed in terms of the way it graphs, but it'll be the same roots. What if I multiplied right here by 2, and I picked 2 because of the denominator, and here by 2? I haven't really changed the equation because I've multiplied both sides by the same number. Now, why did I pick 2? Because this denominator was 2. Now, I'm going to distribute it only into this factor here, so I get 2x minus 1, and then times x plus 5. And notice on the right, this didn't change at all. It's still 0. So it's still a quadratic in the form. We've got a little different, it's been stretched a little bit here, but we can now come up with a quadratic that has no fractions in it. So I got 2x squared plus 10x minus 1x minus 5, or 2x squared plus 9x minus 5. Now, A, B, and C are all integers, okay? And that's kind of the goal, is to to write an equation given the roots that has A, B, and C are going to be integers and not fractions. Let's do another one, and then you can cut loose on the homework here. All right, here's a problem that they've given us 2 roots, and they say, we want you to write us an equation. If these are the 2 roots, we want an equation, okay? And that equation can't have fractions in it, is what it's saying. By the way, if we were to look at this on a picture, we've got one root right here at a half, and another root at 4/3 would be here. So this is some parabola that goes through these 2 dots. Okay, that's what we're looking for, is a parabola that goes through those 2 dots. Okay, so if this is our roots, then the factors have to be x minus the root, x minus the root. There are 2 factors. If this is the root, then the factor is x minus a half. Remember again that here's something you should have at the top. If the root is r, then the factor is x minus r. Okay? Factor is going to be x minus r. So there are 2 factors, and if we FOILed those, we'd end up with a quadratic. But we can't have fractional values for A, B, and C. And I know that if I FOIL this, I'm going to get fractions in the problem. So we're going to do a little quick trickery here to multiply both sides by something so that we get no fractions. Now I'm going to multiply this factor by 2, and this one by 3. 2 times 3 is 6. So I'm going to multiply the other side by 6. I've multiplied the left by 6 and the right by 6. The left I happen to split up into these two factors. And I did that so that these fractions are going to disappear. So here I go, 2x minus 1 and 3x minus 4. And it's still equal to 0. Now you notice that whether I solve the first one or solve the second one, either one, I'm going to get those roots. This equation is a little different. It's going to be the same, go through the same points. It's just going to be a stretched out version of that same parabola. Okay, it's a different parabola. It's not going to give us the same vertex, but it will give us the same solution. So now go ahead and FOIL this. I get 6x squared minus 8x minus 3x plus 4, or 6x squared minus 11x plus 4, and that's equal to 0. So this is the equation we're looking for. Notice there's no fractions in my answer. Okay, you'll have some more problems like that to do on your homework. So this is something that, this is the one thing that's new in this section. Make sure you follow the rules of setting it equal to 0 first, factoring it, and then using the zero product property. Alright, here's your homework for tonight. Alright, so here's your homework for tonight. Make sure you practice this quite a bit here. You're going to need this, and go back and look at the video again if you have to. Tonight's number 39, page 303, problems 4 through 40 even. We are going to skip a section in the book. We're going to skip section 6-4, and I'll talk about that maybe on the next video. Okay? Take care.